Okay, good morning. Let's start today's lessons. I will show you the. I don't know why can't you see? Yes, I will show the Moodle page at this point. I have added there some formula pages concerning geometry. Here is study material for geometry. This point here, and there I have added some pages from English mathematical handbook, which concerns geometric formulas for area or volumes. I add these there so that you may find some formulas which you will need when you are doing your assignments, calculating them. And I will go through some concepts in Finnish language also, so that you could more easily use Finnish handbooks of mathematics or Finnish formula books in mathematics. But I will not show it from the Moodle, but let's show. Here probably it will work. So let's draw a title. Formulas for areas and volumes. Most common, not everyone. They are in formula books. There are many kinds of formulas and many kinds of figures and solid figures there, but I will only pick the most useful formulas there and the concepts in Finnish language also. If I translate this in Finnish, it would be kaavoja pinta-aloille ja tilavuuksille. Kaavoja, kaava is formula. Kaavoja is plural form of formulas for areas, pinta-aloille, and ja volumes, tilavuus. Tilavuus is same as volume. And we have had some formulas. I think square and triangle already. But let's take this kind of figure. How do you call this? Can you repeat? What? Ruhnole kuopo. In Polish.
Yeah, we call like robot.
Well, in Finnish it is suunnikas. I think in English here it is called parallelogram. Parallelogram. It is somehow hard word for me. I think for Finns it is something that you wrote drum. suunnikas. Actually, suunta in Finnish means direction. You call this direction. It's suunta, and I think it's because this figure has two directions there. These are parallel, and these are parallel sides, and probably that is the reason why it is in Finnish called suunnikas. There are some kind of directions there, and mostly in this case we probably know, for example, this angle here, maybe alpha, and if we know the lengths of the sides, so for example this could be B and this A. It is not so important which letter we use. And now this suunnikas or this parallelogram can be changed to the rectangle, suorakaide rectangle in English and in Finnish. Oh, does it not say? It is not said here. We may change this to rectangle by dividing this in two triangles. If we cut this triangle away and put it in the right hand side of the figure, we get the rectangle. And the base for that rectangle or width of that rectangle would be B, the same as in this figure. For this suunnikas or parallelogram, it only moves a little bit to the right, and this side we need to know, and it is the height or altitude of the figure. So if we use letter H, H in Finnish, H. So the area of this figure is B times H. The same formula as for rectangle would be. But now, if we know only the sides of the parallelogram or suunnikas, how do we find out the height or altitude of this figure if we know A and B and alpha?
How do we know what?
How do we get to know this height of this figure?
Yeah,
this
you
age?
can use so far and get
Yes.
that or with this.
Yes, and how do you get? I'll draw a picture here. If I have here H and A and alpha, so how do you calculate the H?
What do we know now from that time?
We know alpha and
Alpha,
alpha.
yeah, that is opposite over hypotenuse.
Yes. Opposite divided by hypotenuse. Yes. So the formula would be sine alpha equals H divided by A in this picture. So when we solve the H here, we multiply these. So it is A times sine alpha. So in this case, we would draw or write the equation for the area of this figure, B times A sine alpha.
And then also in the parallelogram,
Yeah.
if we draw that triangle, you draw the triangle outside.
This.
Yeah, if you draw the triangle inside, no, the other one, the opposite. No, the other side.
Can you show?
So we have this triangle here.
Yeah.
So if you draw this triangle here, so everything is reflective because
Yes.
you know all these angles and you can also
Yeah, here you meant here. Yeah, that is correct. Yeah, so this is the suunikas or parallelogram. Then I will take this kind of figure. Well, in formula books it is written in many ways or drawn in many ways. I will draw it in the way where I think it is most useful to use this formula. If we have this kind of figure, how do you call this figure? Trapezoid. Yes. In this book it is trapezoid. Actually not, but I know that because this is this trapezoid. In Finnish, in circus there are those artists they're using trapeze. I don't know what is in English. It's the same. Yeah, sometimes it is called trapezi, but it is I think old-fashioned word for this figure. Nowadays it is mostly called in Finnish puolisuunnikas, and it is maybe yes, puoli is half and suunnikas is the parallelogram. So this is some kind of half parallelogram.
Yeah, it makes sense.
Yeah. In that meaning that in that sense that when in parallelogram or suunnikas you had two parallel sides pairs, two pairs of parallel sides. These are parallel and these are parallel. But in trapezoid or puolisuunnikas there is only one pair of parallel sides. These may be in whatever direction. For example, in this formula book, it is drawn in this way, the puolisuunnikas. The important thing is that these sides there are parallel and these may be whatever the direction. And in this book it is drawn like this. But in my experience, I think mostly when you have to use that formula, at least myself, mostly I have met trapezoids or puolisuunnikas in this kind of form. So mostly the one side of the trapezoid is horizontal, and then two sides are vertical, and the fourth side is whatever. But the same formula holds for all kinds of situations. If we mark this side B as base, and these sides they are heights of the trapezoid, and mostly height is marked with the letter H. So we have two heights here. So I will call this H1 and this H2. And this also is possible to derive with the help of rectangle. If we think that in that point there is some kind of middle height of this figure, and I draw a horizontal line through that point. So that gives me a rectangle. And the base of that rectangle is this B here. And the height or altitude of this rectangle is the average of the heights H1 and H2. If you take average of these side lengths, then you get the height of this middle point. So the formula well, there are different letters in this formula book, but there you see that the H is the breadth or width of the figure. In my figure it is B, and this A plus B divided by 2 is the average of the A and B. So here is A and here is B, and their average is this sum divided by 2. So in this case the area would be B times H1 plus H2 divided by 2.
So I don't know whether it's the but also if you draw the square or rectangle inside, and then you find the area of the triangle above.
Yeah.
And add that.
Yeah. You may draw a rectangle here. So this is a rectangle which has the base B and height H1. Yes, and then we have this. Yeah, and we get the same formula with that. And then, well, of course, very common figure is circle. I think we had that word in Finnish earlier. I don't remember correctly. Was it? Did we have the word for this figure in Finnish? Pyöreä is round and pyöriä is to roll. But the figure in Finnish is years ympyrä. Circle. Ympyrä. Mostly I think in earlier studies, I think most of you have learned the formula. Well, what is the formula for area of circle? If we call this R, pi times R squared. This R is radius, and in Finnish säde. Säde. Yeah, that is radius in Finnish.
But like name of a person, I think.
Yes, I think there is also a female name, Säde. Yes. Actually, this in most usual form, this word is what is in English. If there is sunlight there and there comes some to my eyes, so eyes there. What is it? Ray? Is it ray?
Right, yeah.
Sun ray.
Yeah,
Yeah, that means the sunny.
What do we call the diameter?
Yeah. Diameter. Halkaisia. Halkaisia. Halkaista means to cut. For example, I want to warm myself with wooden blocks. I cut those in parts, so it is called halkaista, to divide in parts. So in this case, the D would be this measure here. I think this is the most common formula for the area of a circle, but many times more useful is this formula, which is written here, and which is a formula which uses this diameter here. Because many times in practical life, many times you don't know if you need to calculate the area of a circle. Most time you don't know the radius, but you know the diameter, or you may measure the diameter very quickly and easily. But if you have, for example, I can take that. Here I have this kind of thing here, and many times it is more easy to measure the diameter here than to measure the radius, because, well, actually in this case I see the midpoint of the circle there, but mostly you don't know that, you don't see that, and it is very hard to measure the radius, but it is easy to measure the diameter here, about 5 centimeters in this case.
You can easily divide the diameter by 2 and we got the radius.
Yes, yes.
Yeah, but remember, if the number is too small, it's 0.0000. So it's better to work with it.
Yeah, it's
Because when you are going to divide it by 2, it's a problem.
This is many times quick way to calculate the area. Actually, this is very easy to derive this formula, because as it was said, this diameter is 2 times the radius, or in other way, the radius is half of the diameter. So when we have this formula and we replace this r with d divided by 2, we get pi times d divided by 2. And here we have this fraction raised to the power of 2, so we get the same exponent for both, d squared and 2 squared, and that gives that 4 there. So this is the same as. By the way, this letter, in Finnish we call it P. It is
pi.
Yeah, pi.
Pi.
Yeah. In Finnish we say it P. We have two I's in the word. For example, find the Excel here. Oh. this is Finnish Excel, there are Finnish words there, but if I want to calculate the value of pi in Finnish language, Excel with Finnish language, I will write p and then empty brackets, equal sign and then p and empty brackets after that, and it gives the value of p or pi. In English, if you have English version, it's the same formula, but you take the last I away, so it is pi, pi, and empty brackets. It would give the value of pi. I will take an example where we need to use or make some unit conversions, because many times those are gives problems, because it is sometimes hard to remember how to do these unit conversions in units which are used in area problems. And for example, if we have a circle which has diameter, for example, 1, 2, 3, not 4, let's say 5, to get some imaginary number there, millimeters. And we have to calculate the area of the triangle, the circle. So we will use the last form of the formula we had, because now we know this diameter. So we will get I times 1, 2, 3, 5 millimeters squared divided by 4. These brackets are necessary there because this exponent or power is exponent or power for both the number and both the unit. So these brackets are necessary to be there. So we calculate, we raise to the power of 2 and millimeters squared also. And let's see what does this give us. By the way, if you, for example, in assignments or in any mathematical or geometrical problems, you need pi, the value of pi, don't use the memory, this number from your memory or from your head, because this is too inaccurate in most cases. Try to remember it the longer form, or then use the pi letter or pi button from the calculator. So better to use that. In also, if you are using your mobile phone calculators, there are also pi there. There you get the exact value of that pi.
We discussed when we have an exam.
No, we don't.
Like we don't have an exam?
No. This course you only do these assignments, and this is how you.
Okay.
Yeah. Is it the disappointment?
No, it's fine.
Yeah, it's okay. Mostly the problem is that most of the students in this course are not on campus right now, and it is impossible to arrange any exams. So this is the better way to. And there still are many students have big problems to get to Finland. So we will continue these online lessons also. This is the value of the area in the unit of square millimeters. How do you change that to the unit of square centimeters?
You multiply by 10. No, you change millimeter to centimeter.
Divide. Yes, and if the unit would be millimeter, then we would divide by 10. But what do we do now? Let's take some example here. Example inside of example. For example, if we have square with the sides of 2 meters and 2 meters. Sorry, 2 centimeters. I meant. Too small of the figure. Let's draw a bigger one. It is many times easier.
I remember now.
Yes. And if you calculate the area of this square, it will be 4 centimeters squared. And if you use millimeters, 20 times 20, it gives 400. So the difference is 100 is the multiplication there. Many times it is easy to remember when you watch the exponent of the unit, because you have 2 in this case. So if you are making unit conversions, you every time move 2 steps. So if we have dot here, or I draw this comma here, but it is the same as dot, decimal point there. We have to move 2 steps. So in this case, the area would be in square centimeters 11979, and now point is here. So this 2 you may take from the exponent. And if we continue those unit conversions, the next step would be square decimeters, and again 2 steps. .119.79, etc. Square decimeters. And the last one, if we move to the between those 1 figures there, we get the unit of square meters. how about if you know the area of the circle and it equals 0.765 square meters, and you have to find out what is the value of R.
A equals to R square.
Yeah. And what do we do next to solve the R?
You make R as the subject of the formula. R equals to A over pi.
Yeah. So
And the square root of that.
yeah. Let's divide with pi, so we get A divided by pi equals R squared. And now when we know R squared, we get square root of that, and then we get the value of R. And now we may write the numbers inside of that. Well, actually this unit m squared here, or meter squared, it is inside the square root, and if we are taking the root of that, it becomes again a unit of length, so it will be meters. Let's look at what this gives us. I will draw this intermediate result there because many times it is useful to have there. So this is the number inside the square root, and the unit is meter, and then we take the square root of that. And now if we make unit conversions to the decimeter, what would be in this case decimeter?
Multiplied by 100.
10. Yes. Because now the exponent of the unit is 1. So only one step, or multiplying with 10. So in this case, this point moves there. Centimeter, again the same, one step. This decimeter is quite, not so often we use that. It is, but you have to remember that it is there between meter and centimeter. But actually, I don't so often use that decimeter in any place. But centimeters, or especially millimeters, are very common units. If we round the final result to the same accuracy as the starting value of this problem, what would be the correct rounding? How many figures do I write? If the value of area is given 0.765. 3, yes. Actually not 3 decimal places, but we have here 3 numbers accuracy. This first 0 is not a significant number, or only 7, 6 and 5 are. So there are 3 numbers here. So when we are rounding this number of the length of the radius, we will use also 3 numbers. So this is here you see 3 numbers. And the last digit which is dropped away is 4, so it will stay for 493. So this would be 493 millimeters. Some kind of proof that this is the correct rounding accuracy is that when you take another calculator, it's easier to make some changes there. I will again calculate the same thing as we did. 0.765 divided by I. Here and we get the same result, of course, and this we multiplied by 1000 because we got this value there. So I will put there times 1000, so I will get the same result as in the paper. And now if this value there 0.765 is rounded to 3 decimals, it means that it maybe the correct value could be this kind of value, 0.7645. This is rounded to 0.765. And if I now calculate the value of the radius, I get this kind of value, 493.3. So the same figure as we got earlier, but the decimal there is not correct, the same. Here it was 4 and now we get 3. And it tells us that actually we don't know the value of radius more precise than in the accuracy of whole number. This first decimal is not, we don't know that for sure, because this value there is not the exact value, it is only, or we may think that this is rounded value to 3 decimals. And the same as if I change the value there, it would be 765499999. This is also a number or value for area which would be rounded to 0.765. And if I calculate the radius with that value, I also get 493.6. Actually, this would be rounded to 494. Yes. So this is the actually this is not the correct. We don't actually know that for sure that it is in three figures 493, but mostly we get the correct rounding when we are using the same amount of figures as we had in the starting value problem.
Yeah. So are we saying that we round it to the nearest whole number?
Yes.
Decimal place?
Yes, in this case, yes. Nearest whole number. it is quite near 493.5 the value, and that's good. That makes that we actually have a possibility that this radius might be 494 if it is rounded to whole numbers. Well, this is not I would say not so important thing this rounding, but mostly when you are calculating or making some reports from your calculations, it is not wise to draw too much decimals, and it is not wise to write too few decimals. So this rounding method, where we use the significant numbers of the starting values, it gives mostly reasonably exact answer, which is easy to remember and easy to read. When I made my master's thesis, I had one problem there. I made temperature measurements there, and I made some calculators with the help of those measurements, and my thesis is terrible to read. I was young then, and I knew nothing about the roundings, and my thesis is full of these kinds of numbers, and it is impossible to read because every number has 10 decimals there, and nobody told me how to do that rounding to make it readable.
Yes, and is it the actual interpretation of what the figure is representing that is going to determine what you are going to do? For example, if the figure is representing human beings, for example, or if the figure is representing things that could be, like if you are going to count them, they cannot be represented in decimals.
Yes, that's correct. Yes, in these geometry problems, mostly the answers can be what kind of decimal number ever. But for example, if we are counting, making some survey of opinions, we don't say that 4.56 persons was in this opinion. So of course, then the rounding would be to the whole number. Yes. Let's have a 50 minutes break.